Hey, amazing people. We're going to start a topic on algebra. And in algebra, I know often it's really easy to get a little overwhelmed by this topic. Now, algebra is essentially where we do maths, where we don't know the numbers. Okay, so most maths which we've completed always involves numbers. But now we're going to start to look at some mathematics where we don't know what those numbers are. And so what we're going to do is we're going to introduce a few different other topics which we can use to help us. Now, there's a couple of other terms we need to know the names of before we get started here. Now, the first of these is pronumerals. Now, pronumerals, they're simply the letters or symbols that we use in place of numbers. Since we don't know what the number is, we're using a letter in its place. So this, for example, could be where we use X. Other things we might use include Y. We could use the letter A, the letter B, the letter C, really any letter of the alphabet. Sometimes we might even use other funny symbols. We might use something like a star, but this isn't very often. But it's something we could use if we needed to. There are a whole range of different things that we can use as pronumerals here. And all these letters or symbols represent is the number that we don't know. Okay, now another one of these terms we need to understand is an unknown. Okay, since we don't know what the number is, when we use the term unknown, it's just representing the number, whatever that number is. It doesn't matter. Okay, we don't need to worry about what that number is too much right now. Okay, all that matters is we just go, hey, this number is unknown. So it could be X, whatever number X represents is the unknown. Okay, so that's what it means. It's the number represented by the letter. Okay, now another one of these, which we need to be able to understand, is variable. Now, a variable is just describing the unknown number, but in this case, we're saying it can change. Sometimes it could be a number 5, another times it could be a number 10. Now, this idea of a variable we'll look at in a little bit, but it's where we've got an unknown number that can change its value. Okay, now to give an example of where algebra can be useful, I've got this packet of lollies here. Now, this packet of lollies, I want to represent the number of lollies in this packet. Now, I actually don't know how many lollies are in this packet right now. So in order to represent that, because I don't know what the number is, what I'm going to say is instead I have X amount of lollies or X amount of minties. Okay, I don't know what the number is. They could be 10, maybe there's 11, maybe there's 20, maybe there's 100. I don't know what that number is. But whatever that number is in this packet of minties, I'm going to use the letter X to represent that. And that's the purpose here of using an X. We don't know what the number is. So rather than guess, we put a letter in its place to show the value of the number of minties. So now I've got this other problem here where I've got a packet of minties plus 3 lollies. Now, the same as before, I want to use the same idea I used. So first of all, let's just start with the lollies. Now I know I've got one here, another here, and another here. So that's 3 lollies. Okay, so I can write that down. I've got 3. Now, in addition to that though, over here, I've got the packet of minties. Now I don't know how many are in that packet of minties. There could be 10, there could be 20, I don't know the number. So what I'm going to do instead is I'm going to use the letter X to represent the number in that packet. And a way I could represent the total number of lollies is now is I've got X being the number in that packet plus the 3 minties, which I have over here. So this would be represented then as X plus 3, okay, where I squash it together a bit closer. So we've got X plus 3 lollies in this packet. Okay, so that's how I represent it here using algebra. Now, in this example, you can see I've got 2 packets here. So if I have to represent the number of packets which I have right now, what I would do to represent this is, well, I'm going to use X because I don't know how many minties are in each packet. However, what I am assuming here is that the number of minties in each packet is the same in each packet. So there might be 10 in each packet. So I've got 2 lots of 10, which would represent my minties. Maybe there's 20 minties in each packet. So then I would have 2 times 20 to represent that. But because I don't know whether it's a 10 or a 20 or another number, what I'm going to do is I'm going to represent this as 2 times X. X being the number of minties in those packets. Now, one key thing here when we use algebra is often we don't include the times sign. Okay, so we've got 2 times X. Another way I could write this is I can get rid of that times sign, and this is saying the same thing, but I've got 2X. Now, 2X represents 2 times X, but it's just a shorter way of doing it. And it helps us know that whenever you see a number and a letter like that, or sometimes it could be 2 letters side by side, or maybe a number, a letter, and another letter, all of those things are being multiplied together here. Okay, so this here, where I've got 2X, is just representing 2 times X. Okay, so now I've got the same 2 packets from a minute ago. So we know to represent them that we can do this as 2X. So there's 2 packets. We don't know how many lollies are in them, but we're going to say it's 2X to represent the number of lollies. But then we've got these other lollies, which we do know the number of because we can count them individually. So we can see here that there's 1, 2, 3, 4, 5. And so what we want to do then is we want to bring these together. So we've got 2X plus, because we want to add them to it, whatever the number in the packets, plus these other 5 that we've got here. And so the way we would represent this here as an algebraic expression is we would write this as 2X plus 5. And that's what we're doing here. We're representing the total number of minties that we have. Okay, so now in this last example, let's apply the same framework again. So first of all, how many packets do we have? We've got 1, 2, 3 packets. Now we don't know how many lollies are in each packet here. So we're going to represent this by using 3, and we'll just use the letter X again. Okay, so 3X represents just the packets, so we've dealt with each of them. Now we've got these other minties on the side here which we can add to those in the packet. So we're going to add it to it, and we can see here that there's 1, 2, 3, 4, 5, 6, 7 minties on the side here. So that's going to be 7 we add to it. So to represent the number of lollies that we have here, the number of minties, that's going to be 3X plus 7. So there are 3X plus 7 minties here.